Welcome everyone. Let us summarize what we discussed in the last lecture. We said if there was a hexagon and we need to find the area, and we don't know the equation for the area. So some genius comes out with this equation, but there is t, the side, but we don't know how to measure the side. And then somebody comes up with a ruler. So they would keep the ruler along the side, and then you could find t, and then you could find the area. Similarly, when Albert Einstein came up with this equation, actually there are 16 equations in here. This is like this equation. We did not have a ruler, which is called a metric. And we discussed that Schwarsczschild came up with a metric. And the metric was this: ds squared equals 1 minus rs over r c squared dt squared, etc. So this was the metric. So this was the ruler that we could use to solve Einstein's equations. But as I mentioned, the rs include the mass. So our ruler changes with the mass. So it's not a ruler that is unchanging like in real life that if you're going to measure. So our metric changes, the ruler changes, and then with the mass. So this is what we discussed in the last lecture. So now there are some problems with this metric. So the main problem that people saw was when r equals rs, rs is called the Schwarsczschild radius, this becomes 0. That was not a problem. But when r goes to 0, this quantity goes to infinity. So if we take a body, when r is 0, then our distance between this ds squared is the invariant line element, is the distance between two particles, and that becomes infinity. Actually minus infinity, correct? When r equals 0, this becomes infinity. 1 minus infinity is minus infinity. So this is a singular point, r equals 0. And the other point is rs, Schwarsczschild radius, equals to r equals to the Schwarsczschild radius. Then this becomes 1, and this becomes 0, this whole term, and this whole term goes to infinity. So these two were the problems with the Schwarsczschild metric. But people did not take this seriously, what these equations were saying. And also Schwarsczschild had assumptions. He had assumptions. He assumed the central mass is perfectly symmetrical, or a sphere, perfect sphere, and there's a vacuum around the central mass. So if you have a mass, sun or something, all the mass is here, all around is a vacuum. And generally it's true. The central mass is not rotating. That's not true. All sun, planet, everything rotates, but it's very slow rotation. The central mass has no charge. So these are the assumptions he had, and the main problem was with this first assumption. Central mass is perfectly spherical or symmetrical. And people said in nature you don't get perfect spheres. So that may be the reason why we are getting these absurd quantities. So even Einstein didn't believe that there is something called singularity to exist. So that was considered as a mathematical problem, mathematical artifact, has no place in the real world, and people forget about it. But the issue was there. Why that the equations are showing us these nonsensical value, this going to infinity and this is going to infinity. And this issue, so the scientists thought, well, this is just equations, they have no real meaning. Until there was a scientist called Subramaniam Chandrasekhar, that he came up with another idea. And then Schwarsczschild radius and Chandrasekhar's ideas coming together, now people start to take this issue seriously. So in our next lecture, we would see what Chandrasekhar came up with. Thank you very much.